Hello everyone. In this lecture, we are going to solve problems on one property and one theorem. The property is Z transform of e raised to minus an f of n is equal to f of e raised to a into z. That is, whatever the Z transform of f of n is, f of z, in that replace z by e raised to a into z. And second one is convolution theorem, which is defined as Z transform of convolution of the two sequences f of n and g of n, which is denoted as f of n star g of n, is equal to the product of Z transform of that two sequences, that is f of z into g of z. So let us go to solve the examples. Examples: find Z transform and the region of convergence for the following sequences. First sequence is e raised to minus 2n sine 3n for n greater equal 0. In this solution, first of all, we will call this sine of 3n as g of n. So g of n is equal to sine of 3n. Now, we will use Z transform of some standard functions, and here that standard function is sine an, and its Z transform is z into sine a divided by z square minus 2z cos a plus 1 for mod z greater than 1. Replace a by 3. Replace a by 3. Hence, Z transform of sine of 3n will be z into sine 3 divided by z square minus 2z cos 3 plus 1 for mod z greater than 1. Now, to evaluate Z transform of the given sequence, we recall Z transform of e raised to minus an g of n is equal to g of e raised to a into z. How to evaluate this? This g of z is the Z transform of g of n, and in that replace z by e raised to a into z. That will give us Z transform of e raised to minus an into g of n. Hence, Z transform of the given sequence f of n, that is of e raised to minus 2n into g of n, is given by z into sine 3 divided by z square minus 2z cos 3 plus 1 mod z greater than 1, and in that replace z by e raised to a into z, that is e square into z. So replace each z by e square into z. That will give us e square into z sine 3 divided by e square into z bracket square minus 2e square into z cos 3 plus 1, and in modulus also replace that z by e square z. That will give us mod of e square z is strictly greater than 1. Now simplify it further. That will give us, it is e square z into sine 3 divided by e raised to 4 into z square minus 2e square into z cos 3 plus 1 for mod z greater than 1 upon mod of e square. Now take e raised to 4 common. That will give us this expression where the denominator is becoming now e raised to 4 into z square minus 2 into e raised to minus 2 into z cos 3 plus e raised to minus 4 for mod z greater than mod of e raised to minus 2. Take this e raised to 4 in the numerator, then perform the multiplication. Hence, final z transform will be e raised to minus 2 sine 3 into z divided by z square minus 2 into e raised to minus 2 into cos 3 into z plus e raised to minus 4 for mod z strictly greater than mod of e raised to minus 2, which is the region of convergence. And this one is required Z transform of the given sequence. Now let us go to the next example. Second sequence is f of n is equal to 1 upon 2 raised to n star 1 upon 3 raised to n. So this is convolution of the two sequences for n greater equal 0. In the solution, we are going to obtain Z transform of these both the sequences 1 upon 2 raised to n and 1 upon 3 raised to n separately. So in the solution, let g of n is equal to 1 upon 2 raised to n. Hence, its Z transform will be given by g of z equal to Z transform of 1 upon 2 raised to n. Now use the definition of Z transform. It will give us summation n equal to 0 to infinity 2 raised to minus n z raised to minus n. Put the values of n one by one, that will give us for n equal to 0 it will be 1 plus for n equal to 1 it will be 2 inverse z inverse plus for n equal to 2 it will be 2 raised to minus 2 z raised to minus 2 plus so on. Simplify this expression, it will be 1 upon 1 minus 2 inverse z inverse, because for this expression is in GP geometric progression with first term as 1 and common ratio is 2 inverse 2 raised to minus 1 z raised to minus 1. Hence we got the sum as 1 upon 1 minus 2 raised to minus 1 z raised to minus 1 with modulus of common ratio strictly less than 1. Therefore, g of z, simplifying it, we will be getting it as 2z divided by 2z minus 1 for mod z greater than 1 by 2. So that is Z transform of the sequence g of n equal to 1 upon 2 raised to n. Now we will go for obtaining Z transform of the sequence 1 upon 3 raised to n. Now consider h of n as 1 upon 3 raised to n, and in same way we will try to obtain Z transform of the sequence h of z. Therefore, using the definition, we will be getting again summation n from 0 to infinity 3 raised to minus n z raised to minus n. Put the values of n one by one, that will give us 1 h of z is equal to 1 plus 3 raised to minus 1 z raised to minus 1 plus 3 raised to minus 2 z raised to minus 2 plus so on. Which is again in geometric progression with first term as 1 and common ratio as 3 raised to minus 1 z raised to minus 1. Therefore, infinite sum is given by 1 upon 1 minus 3 raised to minus 1 z raised to minus 1 with modulus of the common ratio 3 raised to minus 1 z raised to minus 1 strictly less than 1. Simplify the expression, hence Z transform of the sequence h of n will be h of z is equal to 3z divided by 3z minus 1 for mod z strictly greater than 1 by 3, which is the required Z transform of the sequence h of n. Now we will go for obtaining Z transform of the given sequence f of n using convolution theorem. Convolution theorem states that Z transform of convolution of the two sequences g of n star h of n is equal to product of their Z transform, that is g of z into h of z. Therefore, Z transform of the given sequence f of n, that is g of n star h of n, is equal to the product of 2z divided by 2z minus 1 into 3z divided by 3z minus 1. And here the region of convergence is mod z greater than mod of 1 by 2. The number which is bigger out of the two, that is 1 by 2, that it is the number maximum of 1 by 2 or 1 by 3. So it is 1 by 2. Hence the region of convergence is mod z strictly greater than 1 by 2. This is Z transform of the given sequence f of n, which is 1 upon 2 raised to n star 1 upon 3 raised to n. I hope you have understood this. Thanks for watching this video.